So this is a GMAT problem that uses a very specific algebraic trick, which is called by various fancy names. Some of them are rationalizing the denominator or multiplying by the conjugate. The basic idea is that if I have the square root of a minus the square root of b, capital A and capital B can be anything, times the square root of a plus the square root of b. I'm going to distribute this out step by step just so you can see what happens, but I'll also go ahead and give you the answer right away. The answer is going to be a minus b. Now, square root of a times the square root of a is the square root of a squared. And let's see here. Square root of a times the square root of b will end up canceling with minus the square root of b times the square root of a. And then finally we have minus the square root of b times square root of b. It's going to give us minus the square root of b squared. So these two terms right here cancel each other out. We are left with the square root of a squared minus the square root of b squared. Square root of a squared, of course, is a. Square root of b squared, of course, is b. And the end result is a minus b. If you look closely, this is nothing more than a difference of squares. Let me erase all this mess here in the middle. And let's say we started with a minus b, and for whatever absurd reason we decided, hey, let's write this as square root of a squared minus square root of b squared. Then the factorization of that as a difference of squares is exactly the square root of a minus the square root of b times the square root of a plus the square root of b. So there's just a general algebraic overview of what's about to happen, which is we are going to multiply the top and bottom of this fraction by a well-chosen version of 1, which is what a mathematician calls square root of n plus 1 plus the square root of n divided by the square root of n plus 1 plus the square root of n. This item that we're multiplying, 1 over the square root of n plus 1 minus the square root of n in these square brackets here, that's just 1, of course. Now, the numerator is just going to be root n plus 1 plus root n, and the denominator is exactly one of these root a minus root b times root a plus root b, which we just demonstrated was a minus b. In other words, in this case, it's going to be n plus 1 minus n. And of course, n plus 1 minus n is just 1. So the end result is the square root of n plus 1 plus the square root of n. Now let's just check this. They say if n is positive, which of the following is equal to this? Well, we ought to be able to plug in any specific numerical choice for n, and I'm going to show you that we can take n equal to 1, and it's very useful for the GRE or the GMAT if you know that the square root of 2 is about 1.4, and if you want to even be more precise, it's about 1.41. So 1 over the square root of 2 minus 1 is about 1 over 0.4, and I'm going to do mental arithmetic that may aggravate you, and that's 2.5. Now, if you just look at all of the answers here, which one of these is going to give us, so we did n equals 1, and I'll just write it out again up here. 1 over root 2 minus 1 is 1 over 0.4, which is about 2.5. Now let's just look at what all these answers are. 1 is obviously not close to 2.5. Square root of 2n plus 1 would be the square root of 3, which again, it's useful to know it's about about 1.7. Square root of 2 divided by 1 is about 1.4. Wrong, wrong. Root 2 minus 1 is about 0.4. Wrong. And we're left with root 2 plus the square root of 1, which is about 2.4. Like I said, this is not an exact science, but 2.4 is close to 2.5. So I always like to illustrate some way to do problems using numbers, and in this case I'll close by just saying root 2 is about 1.41, root 3 is about 1.7 something, I'm not exactly sure. It's useful to know that 14 squared is 196, and 17 squared is 289. Knowing both of those things kind of hints that, if I square both sides here, I'll get 3 is approximately equal to 2.89. So, did a little review of algebra with multiplying by the conjugate, rationalizing the denominator, fancy words for using the difference of squares formula to get rid of the radicals in the denominator here, and also illustrated that you can check your answer by simply knowing that the square root of 2 is about 1.4. Hope you learned something.